All right, now we're going to work to find vertical asymptotes in situations where we have to decipher that there are actually some holes in the process that we want to not call vertical asymptotes. So it always starts with factoring to identify the points of discontinuity. Step 0 is called step 0 because it's actually step 1. Identify points of discontinuity by factoring in the denominator. So we want to set the denominator equal to 0 and identify what would cause issues because we cannot divide by 0. So we factor. I have a GCF here of 3. So I'm going to get 3 times x squared plus 3x minus 70. And then I can use the magic x to further factor that trinomial that's on the inside there. And on the top of the magic x, I multiply my a times my c value. So it should be negative 70. And at the bottom, I should just multiply or bring the 3 down there. To figure out what multiplies to be negative 70 and 3, I'm looking at 10 and 7. 10 times 7 will get you 70. And if one of them is negative, I'll get negative 70. Well, I want the 7 to be negative so that I have a difference of 3. And so that allows me to factor the trinomial component to be 3 times x plus 10 and x minus 10 and 7. Now, the only reason why I can jump is from the magic numbers to the magic factors is because there's a 1 there. And if there was a different number, I'd have to use the x group method we've previously discussed. So each one of these factors, you set them equal to 0. 3 divides out, so it's not part of the process. It just goes away. And then you set x plus 10 equal to 0 and x minus 7 equal to 0. That gives you x equals negative 10 and x equals 7 as points of discontinuity. Now, these are points of discontinuity. That's the result of our step 1. So basically, we just figured out the domain is all real numbers, except that x can't be those two things, negative 10 and 7. Our job now is to sort, but we sort through step 2. We have to factor the numerator to see if stuff cancels. So I look up top, and I see another trinomial that needs to work the x method. Multiply a negative 20 times 1, a times c value, bringing a negative 20 up top of the x, and then an 8 to the bottom of the x. And then I just have to figure out what multiplies to be 20 that adds to be 8, and that's going to be 10 and 2. So I'm looking for a negative 2 so that it subtracts to be a positive 8, multiplies to be negative 20. So the top factors to be x plus 10, x minus 2. Now, what we're looking to have happen is whether or not things are going to reduce out. And I can see right here this x plus 10 and this x plus 10 down here are going to reduce out, but let's go ahead and clean it up so that it doesn't look like a mess when I just start canceling things. This whole function is now rewritable in factored form to be x plus 10 times x minus 2. And then we've got our 3 times x plus 10 times x minus 7. That was step 2, so that I can do step 3. I factored the numerator, and now I'm looking to reduce so that I can sort. So here we reduce our x plus 10s because anything divided by itself is a 1. And so we cross that out, make it a 1. And I will write my further reduced form function f of x is now in reduced form as x minus 2 over 3 times x minus 7, which is great, but that wasn't the point of the problem. The point of the problem is to now figure out that this x plus 10 connected back over here with this point of discontinuity of negative 10. That negative 10 reduced out. That negative 10 is a hole, not the answer to my question. My question says, what are the vertical asymptotes? So if we put negative 10, x equals negative 10 as a result, we'd be wrong. That is a hole, not a vertical asymptote. So our job then is to focus on this 7. 7 remaining factors in the reduced form cause vertical asymptotes. Because x equals 7 still causes the denominator to be 0, that's an issue. I cannot divide by 0, so x equals 7 is still an issue in the reduced form, so it's defined to be, algebraically, a vertical asymptote, a VA for short, at x equals the vertical line 7. And what that means is on the graph, when I go to graph it at 7, I would put a vertical dashed line, because right there the graph either approaches from left to right to positive infinity or negative infinity for both sides. We're heading that direction. That's a conversation for another day, but that's where we are going.